Hello, everyone. We're excited to have you here for another webinar in our series for the Docker AI Machine Learning Hackathon. My name is Michael Irwin, and I'm part of the developer relations team at Docker. If you're new to this series, and if you're new to the hackathon, we'll drop in and chat here in just a moment a link to DevPost, who's helping us run our hackathon. Again, we're super excited to be hosting this and to have some distinguished guests here with us as well too. Um, if you're joining us, feel free to drop any questions you might have live into chat, and we'll be happy to answer them, respond to them as we're going throughout. And this session will be recorded, it will be shared on YouTube, but also it will be shared on DevPost as well too, as well as all of the other previous sessions that we've had, and lots of other resources and links available too. I'll go ahead and also call out to there in the resources is a link to our Slack workspace where we have a channel that's completely dedicated to the hackathon as well too. So if you've got questions or you need help or just even ideas on things that what can I build and how do I think about this? How do I approach this problem space, et cetera? That's a great place to get some additional resources and help. And so with that, I'd like to introduce our two guests here. We've got Varun and Ayush, who are joining us from Navan, and they're going to be talking about computer vision AI and lots of great things. And I don't want to steal the thunder from them, so I will pass it off to them and let them continue to introduce themselves. And again, welcome. We're glad to have you.
Hello, I am Varun and Navan.ai. So just a second while I share my screen and share the presentation. Okay, so while the presentation is loading up, I'll introduce myself and Ayush, who we have with us here. We also have Santosh here, who may not be visible right now, but so I'll just introduce all of us from Navan.ai. I lead marketing at Navan.ai, and I have been in touch with, or I keep talking to developers, businesses, most use AI. So my screen is now all right. So here's the presentation. All right, so just continue with what I was saying. I keep businesses, a lot of people who want to use AI. Understood. They want to use AI, but they don't know how to use AI, and they don't have AI. So that's what we have noticed so far. And even from our experience, we have had multiple learnings from our experience as well. So that's how we came up with Navan.ai. And today, again, thanks to Docker for hosting us. And today we are going to be talking about how you can use Navan.ai to build computer vision models and deploy those computer vision models seamlessly using Docker. So that's what we're going to be focusing on mostly today. And so again, coming back to who we have today, we have Ayush with us. He is leading the AI/ML team at Navan.ai, and Ayush has also been he's been quite passionate about teaching. He has taught AI to like machine learning basically to multiple people. Before joining Navan full time as well, he was helping people learn how to use machine learning, how to work on machine learning. So, and he's had several other experiences to his kitty as well. And along with Ayush, we have Santosh here. Santosh is the founder at Navan.ai, and he's had several years of experience in the IT services and AI industry, and he's done phenomenal work based out of Singapore, working with several enterprises, helping people, helping businesses basically get started with their digital transformation and now AI transformation. So coming back to Navan.ai, who we are, I'll just move on. We founded ourselves in 2022 as like a separate Navan.ai, and this year in Singapore itself, which was January in this year, January 2023. We formally registered ourselves in Singapore, and now we have offices in India as well. We do work with a lot of partners globally, especially in Asia, and a few of them in the Middle East and Europe, US, and so on. So that's about us. And coming to the main part, which is what Navan.ai does, right? So our mission, the objective that we started off with was to make AI adoption easier and faster. So again, coming back to what I was saying earlier, is that when we were talking to several businesses, we understood that they wanted to use AI, but they didn't know how to, and they didn't have the expertise to. So that's how we came up with this entire idea. Plus, our experience also helped us shape this. Was that The idea was that we need to have something which removes the complexity of the process from the process, right? So that's how we came up with a no-code platform, which helps people to work on computer vision, which helps people, developers, especially non-AI developers, to build and deploy without having to learn how to code for AI and learn how to deploy stuff, learn everything about ML ops, DevOps, and so on. So that's how we came up with the platform. We've been working on it since last year, and so far we have a platform where we've integrated image classification and object detection models, and I'll just be talking about that a little ahead from here. So again, we have, in terms of our business, we have in studio, which is where you can build any computer vision model. It literally takes like a few minutes to build your computer vision model. Then we have in cloud, which is a cloud offering where you can deploy a computer vision model or a generative AI model, and you can even upload your own computer vision model, and get the API endpoints from there directly to integrate. And this hardly takes a minute to deploy the model, right? So that's what we are doing, which is like the cloud offering and the studio basically where you can train. But cloud is one way of deploying the model, right? The other ways that we sorry, the other ways that we help users to deploy the model are, again, one is Docker, which is like a seamless integration, and you can use Docker to deploy your computer vision model that you've trained on in studio. And also, the most basic option is downloading your model files directly from in studio. And again, in terms of businesses, we have a third unit which is about consulting and solutions. So we also provide AI consulting. Let's say a business wants to know how they can adopt your AI or how they can automate processes. Then we provide them with that guidance and implementation both. So our expertise mostly lies in computer vision, LLMs, and generative AI. So those are the solutions around which we work mostly. All right, yeah. So I'll have Ayush. So Ayush and I will be presenting at different points, and we'll keep switching. But Ayush, maybe you can just continue talking. I'll share my screen here.
Sure, thank you. Thank you, Varun. Hi, all, and I'm Ayush. As Varun explained, we are our expertise in computer vision, and here I'm going to present some basic things about computer vision, and I hope it will help you to understand more about what we do and what our motive is for today's webinar. So yeah, we can start with the basics of computer vision. For going further, we just need to understand what is computer vision basically. So it's not a big science to understand over here. It's very simple. If we understand what is the difference, or rather I'll say what is the similarities between human vision and the computer vision, then it will help us a lot to understand more about how computer understands image or a video. So let's start with very basics. Here we can see the image where we have explained how human vision works. So human, when as a human or as any animal, when we see to any object, so let's consider eye as a sensor over here, which is very similar to the camera. So human camera is nothing but eye. So any object when I catches, what happens is like I sense the sensing image, or what do you say, whatever it sends to the brain, and brain is someone who is going to work on whatever I is sending, and it is going to interpret whatever it sends to it. So if you see, there's a bowl of fruits, and I is trying to catch this from as a sensor. and it's sending to the brain. Brain is able to identify whether what are the fruits are there in the bowl. Similarly, in computer vision also, when a sensing device or a camera sense anything and sends the signals to the device, what happens is like computer vision is going to work on the sensors, work on the sense signals, and then it is going to interpret on top of that and understand what exactly the camera is seeing. How it is going to do that, we are going to see in the next slide. Yeah. So what happens is like image processing is a very basic fundamental thing which helps a machine to understand the image. So in digital image, all the image is made up of pixels. Pixel is a minute unit of any digital image. And what happens is like it is made up of three different channels. Let's talk about RGB. So it's going to be made as a channel, and these three layers or these three channels, what is going to happen is all these pixels, the machine is going to read all these pixels, and through the computer vision technology, or let's say through the AI or through the machine learning, we are going to read the pixels pattern, and those pixel pattern are considered as so whenever you are going to tell that okay, this pattern looks like apple or this pattern looks like orange, you are going to teach machine at the end that okay, this whatever you find this kind of pattern, you are going to consider that as an apple or this as a particular object. So machine understand that, and it starts understanding the pattern, start finding the pattern from whatever image or whatever video you are going to provide, and it will detect or it will classify that image accordingly. So yeah, but on next to see. Yeah. So here what we are trying to see the similar thing that let's say if any neural network, how the neural network works is like there are different layers. On through the layers we are going to do multiple calculations. It's going to be matrix calculation because as I said that there are three different layers when it comes to the RGB, and three different layers consist of matrix which are like 3D matrix, and all these metrics are going to be passed through different layers. This is how a neural network works. So whenever you are going to build a neural network, it is just to find out the pattern. So at the like at the larger level, we can say that if you want to classify between cat and dog, so you are going to give a lot of images to the neural network, and neural network is learned on this basis of finding patterns. So whenever your neural network is deployed and going to act on any kind of image, it's going to just find whether it's a cat pattern or it's a dog pattern. Now when we say cat pattern and dog pattern, it's just very similar that how the eyes pattern or how the eyes area pixel looks for cat and how it is for dog. It's going to just make a difference between both of them because it is made, we have made it in such a way that it can identify the difference between cat and dog. So when you are going to pass any image through this, it is going to understand okay, this looks like cat's eye, or this looks like cat's whiskers or ears. It is going to give you output accordingly. So yeah, this is what exactly computer vision can do. It's not that it can only classify, but it can also detect a particular object along with the location. I think that's what we are going to see in the next slide.
All right. So again, so we've currently on Navan.ai we've integrated image classification and object detection model. So the first thing would be again. So we don't know what's your level of expertise, understanding of computer vision, but for the sake of or for the advantage of everyone, and for the sake of basic understanding for everyone, what I would logically look at it is that or how I would differentiate between these two in terms of application would be that if you have, let's say, one object in the entire image and you want to know which object is it, you want to basically classify which object is it in that image, then you should ideally use a classification model. Now again, there are multiple variables around it, but this is the kind of the base logic that I use at most of the time, most of the times. And if you have multiple objects in the image and you want to know where each and every object is located in the image, then you should use object detection. So this is again like a basic difference between when you should choose image classification and when you should choose object detection. So here in this example, what we're seeing is that there's one image in which there's only a cat, and we can use classification for that. But there's another image in which there's a cat, there's a dog, there's a duck, and then if we want to know which objects are there, basically, and we want to train the model to learn that, to tell us that, to predict that, then we use object detection for that. So these are the steps, and I will just run you through the entire process.
So as I explained and as Varun continued, we are going to find out these patterns and we are going to make the neural network. But when we see at all these technical things, it becomes very overwhelming. So let's go step by step. And I would like to help you to understand where Navan AI is going to help in all these procedures. So let's talk about the very first steps, which is like identifying the problem. So here, wherever you want to create a computer vision application, first of all, you need to identify what exactly you want to detect, because this is the start where, let's say, let's take any kind of example that I want a fire detection model needs to be trained, or let's say I want a fire detection model to be trained just for my organization, or wherever, let's say a warehouse I'm having, and I want to build a fire detection model for that, just to make sure that wherever such fire accidents happen, the CCTV can identify that at a very first step, and I can take an action on top of that. So if this is what your business problem or any such kind of a problem which can be solved through computer vision, then this is your step one to identify it. And when it goes to step two, you need to define exactly what you need to take as an action, or exactly what you need to identify. So when we are taking this example as a fire detection, so at the end your CCTV needs to identify the fire, any source of fire which can lead into the big accident. So the step three is going to be determining the appropriate computer vision model or the technique. When I say model here, because okay, we are going to talk about obviously neural network, and it is going to create an AI model, but it can also refer as a technique. So which exactly technique in the current era is used for this particular problem? Here, this basically is a very large topic. So there, if you go into the internet, and if you go to the community of the development, you will see lot of models available there, from basics to high end. So here, what Navan AI can do is like give you a best suitable model template, which can be easy for you to identify, and you can even try it by your own. And this will help you to start your AI model development at a very basic level, where you don't have to go through all these codes and all these kind of frameworks. And if you think that okay, I'm not a coding guy, or let's say I'm not having any kind of a technical knowledge for that, that's completely fine, because Navan AI is going to help you. That's what our complete aim is, to make AI available for everyone. So you don't have to worry about the coding part, but here just you need to select the model template. So once you select that, you need to go to the step 4. And here you need to just understand that what kind of a data I need to give to this model template, so that the model template, whatever model is there, is going to train on this custom data and can act for your particular business problem, or for your particular use case. So here also again, Navan AI is going to help you to get a data. I mean, you can upload the data over there. You can start annotating that data. You can start labeling that data. It's all the tools are available in Navan AI. So whatever data you're going to store in, you need to be manage it well. You need to store the data. You need to store the annotation, so that later also, whenever you want to go ahead and train it for multiple iterations, you can see your data stored over there. You can see the kind of a repository you can see over there. So yeah, Navan AI is going to help in the step 4 also. Let's go to the step 5. So here exactly whatever data you have given to Navan AI platform, or whatever data you have used for your particular use case, we are going to train on top of that. And the training and everything is going to be completely without writing a single code. So it's just a one click. where you have given very simple setup. So even if you are not aware about what configurations to be used while training the data, we can have a best suitable configuration for you, which are set as default. Even if you are thinking that, okay, I have some of the knowledge about model training and I want to test something, or let's say I want to do some kind of a tuning, fine tuning, and I want to also try some kind of a changes in hyperparameters. You can very well do that because we have given three different hyperparameters to tweak in between, and you can test with that and you can get a best suitable um, accuracy and metrics for you, and you can keep on trying that. You can track the experiment whichever you do on the platform. So you can train and evaluate the model, so you can train it for multiple versions. So if you say that the first time I'm training and I'm not happy with the model, you can still upload more data, you can still label more data, and you can use that data again for the next cycle, and you can again change multiple things in the configurations of hyperparameter. And after that, when you're happy with your model or any kind of a version, all these kind of versions which you are going to train are going to be saved as a model repository or as an experiment tracking. And after that, you can select one which is suitable for you, which is the best model till that model you can very well deploy and test. So before deploy, you can test it, which is nothing but step 6. You can test it on the Navan.ai platform itself, and then you get three different deploy options. You can export the model as a file. You can export even the code which we are given, which we are giving you to test on your local system or your servers. And I must say the very favorite options of all the developers all the time is Docker. So you can export it as a Docker, and you can use that. You can use a Docker image which we already have in the public repository of a Docker Hub. That base image you can download, and you can use that base image with whichever model you have trained. You can download that model, and it's just a simple commands, just Docker run, and giving these arguments as a Docker file, sorry, as a model file, and whatever arguments are required. All the documentation we are helping at Navan AI platform. And the last option is very again favorite by developers who want API access of all these models. You can deploy it as API on Navan AI platform, again on the Navan AI servers, which are 24/7 available for you, and we can serve these APIs, and you can use these APIs and integrate with your application wherever you want. You can integrate even on your devices or on whatever application you want to build and wherever you want. So this is going to be very favorite option for many even data scientists, because the skill set required for deployment and into the production is completely different than a data science. A data scientist. So we are going to help you in that, and we are trying to make it in optimized level, so that you can only focus on the development of this very super no code platform, and not to worry about the deployment part. So the step 7 is again, you need to think about, to iterate the solution. Let's say if the model is going to decay after some time, you can again come back to the Navan AI platform, and you can still upload more data and iterate your training and understand what is your or rather evaluate the model, and again do the same thing. Thanks.
All right. Yeah. There are a few challenges which are faced by anyone who build a computer vision model. But so Ayush can explain
Yeah.
this a bit more in detail. Yeah.
Yeah, sure. So these are few kind of jokes I got from internet, that whenever the model is trained to find out dogs in these images. So yeah, these were the outputs, that all of these even the fried chicken was considered as a dog, or even the mob, a cleaning mob is considered as a dog. So these are few limitations even computer vision faces, because again at the end it's just a technology, and even a man or even a human can get confused with all these images. So what happens is, like, when you talk about the evaluation of the model, that is very much dependent. The outputs is very much dependent of the data quality you are going to give to your model. So let's say if your data is very confusing for anyone to process, or let's say it is confusing for the computer vision technique, then these kind of limitations you can face. That okay, multiple things are looking very similar, it's not able to categorize between two different things, then you might get quite bad results. That is possible. Secondly, if you are giving us insufficient data, I mean you're not going to give, if you are not able to give a proper amount of data to the model to be trained on, then this kind of again situations are. Then the data imbalance is something which is very commonly we have seen, that people try to make a categorization model or classification model, and then there are two different class, and one class is made up of large amount of data, but they fail to give a similar amount of data to the second class. Then model is going to learn more on the first class or the class which have more data, and it can be inclined model towards that class, so that we can keep it in mind, and we need to give a balanced data for all the classes. Again, sufficient data as well as balanced data. So if you think that okay, 100 images or let's say 500 images are sufficient, then those 500 images are going to be equal in all these classes. Again, data variation is something which we need to keep it in mind, that whenever we are putting the data, and we are expecting few things to be identified from the model, then those data should be those data samples should be there in our data set, so that model can identify okay, there is a difference between these kind of a variation of. So to learn on different patterns, so at the end, if you keep just in mind that we need, I mean the model needs to understand pattern from all of these, then you need to keep it in mind that all these variations or all these variations pattern should be there in the data set. Next thing is again very common, but I mean we can solve this. That is poor annotation. So sometimes you need to annotate some complex things, and what happens is like while annotating, you annotate it on the correct location, or you may not annotate it in the correct location. There are different false what do you say, things which happens in the new. It's kind of a human error. So if such annotation happens, what happens is like that same data is again going through all this neural network, and again machine can understand it differently, which is not expected. And then last is model template selection. So when it comes to classification, as Varun very well explained, that the classification and the object detection is completely different two things. If we are able to understand that, and if we are able to exactly select the model template, or let's say even if you go to the classification, we have around 3 to 4 different templates, and all those templates has their own use cases. It's not that this is best or this is worst, but it's all about your use case. So if you want to identify something like a microorganism level, which is going to be very very similar to each other, like two different classes are there, but still they are very similar and there are many very minute differences, then you need to go for the model which is having, I mean which is built on more parameters, like the large set of parameters. But if it is just a small difference, just like a cat or a dog, then or apple or orange, such kind of a difference in the image, you can very well go with the lower end models, lower end in the sense lower parameter models, and you can train on that, which will be easier for training as well as faster. So you need to understand what is your use case and select the product. Yeah, and the next thing is about when we are talking about the data feeding, and when we are saying that you can upload your data, the first question arises that what will be my privacy, what will be happening with my data. So you need to just relax on that topic. So what we do is like we are taking care of your privacy. This data is going to be safe with Navan.ai platform, and we follow all the privacy regulations, and there won't be any kind of thing which you need to worry about when it comes to the privacy, not from even Navan.ai and any other users or any other kind of attacks which happens generally. So we are going to take care of these kind of concerns, and yeah, your data is safe with us.
All right. And moving on. Okay. So I think, okay, yeah, sorry. So there's this case study or an example that I wanted to share, and we worked on this, so I can give more details as well. But this is the main reason to share, talk about this is to give you an example of how you can use computer vision for a large scale implementation, right? So we've worked with a beverage company, and what we did was the objective of that the objective was to reward you by right? So scale and everything is fine. I just mentioned it here, but to a good amount of accuracy because this is more like a B2C thing, and even some difference in accuracy matters ultimately use like end people end users who are going to be affected because of that, and they may or may not get a reward because of the constraints, right? So the scale at which we could operate this, which was more than 4 million units, expected 4 million units a year, and we would be able to achieve 99% plus accuracy for the computer vision models. And the infrastructure is again on the deployment side of it, which was scalable infrastructure which was able to handle 300 requests per second. So the idea again to talk about this is because people think that okay, what are the use cases of computer vision? Where can we use it? How can we use it? Right? So there are like very simple use cases, but the impact is huge, and there are very complex use cases as well, where you're probably just solving it for one customer or one set of users or one segment of users, and still it helps them a lot. And it's probably something that nobody else will do or no other technology will be able to do. So, any questions we can.
I'll just jump in and say there's only so far as there's only been one question that was brought up, and Santosh answered it in chat as well too. So we're looking good so far there. But
All right,
again,
cool. So let's
I'll throw
continue.
this out to anybody else that's still watching. Yeah, feel free to jump in and ask questions along the way as well too. So
All right. So now we're going to be, I'll basically show how you can build a computer vision model right from scratch without any coding, right? So I'll probably take about 10 minutes for this and show different models. So you quickly go to Navan.ai and you can sign up. Just log in. All right. So right now we have two different options. One is with Gmail and the other is with you can use either of the accounts. Just all right, I'll log in from my account. And first off, with a classification model, then depending on the time, we'll decide if we want to go ahead with detection as well or not. And but let's get started with classification at least, right? So again, the first step is understanding the business problem and then going on, like we discussed earlier, the different steps for building a computer vision model. Data is a limitation for everyone mostly. So right now I have a few data sets. I'll use one data set which is going to classify different types of tires basically. And when I say tires, I mean that one class would be where it's a damaged tire. The other class is where it's a normal quality or a good quality tire image basically, right? So to save time again, on this platform, when you go to image classification, you have these 5 different options. 5 different versions of EfficientNet that you can use. And if you're confused which version you should use, then you should look at, you can just hover on this eye icon and you'll get some examples for each and every model version, right? So you can look at that, or if you already know which is the right version or right model for you, you can directly go ahead and choose that. To save time right now, to save time in training basically, I'll go ahead with B0 and show you the process. The idea of this is to show you how you can build something without coding in just a few minutes, right? So I'll take that same example which I was talking about, which is tire classification, and I'll create one class which is where I'll upload images of normal tires. So I'll just name it as normal, and I'll create another class which where I'll upload images of damaged tires. All right. So I've created classes, and I'll just be adding image folder, but add the images and you'll be able to see the images here. So let's go ahead. About 22-ish images. So 20 images are the minimum that you need to train them right now. 22-ish. And so this is a classification model, right? You don't have to do labeling separately. The naming different classes itself is as good as labeling here. But for an object detection model, you will have to annotate the different objects in the image, and that would be the annotation or the labeling part of it. All right, so I've added about 22 images of different tires which are in good quality, or images which show that tires are in good shape, good quality, or normal quality, or what normal tires should look like basically. I'll add almost same number of images in the other class, which are images of damaged tires. So it'll just take another minute. So one thing that you keep in mind, which was also discussed in that slide where we talked about the steps, is you should have balanced number of images in all your classes, right? And if you want to have more classes, you can just add another class and start and like add as many classes as you want basically. So I've added like 22-ish images in both the classes, and the only thing that I have to do now is click on start training button, and it'll start training on the cloud. And you can also check the progress of the training here. So it has started, and it probably take about 1.5 minutes to just finish this. Not even 1 minute, I think. Yeah. So while this is happening, what I'll do is that, so I wanted to show it till here with this model, and because this model has very limited data, I don't think it'll be right to test this model. What I've done is that I've created a similar model with a bigger data set for the same images, for the same use case basically, and I'll show the testing process from there. But then I'm just waiting for this to complete training, less than a minute from now. Meanwhile, if there are any questions, any additional questions, we can take up.
It's actually good timing because one just came in as well too, and I was waiting for a quick moment. So Gabrielle asked more of just a heads up as you're going through your demo, but she asked, as you're going through your demo of how to build a model, can you go over how to add parameters slash hyperparameters as well?
Oh yeah, thanks for mentioning that because I just forgot to show you that. But once the training is done, I can show you how to do that.
Sure.
Okay, while this is taking a bit longer, I'll just go back to the other model, the similar uh, data set, and show you the entire version. And I can show you the all right, yeah, here. But the only difference was that for this model, the number of images that I added were 3. for each class, and I selected efficient B3 version instead of a B0 again. So coming to the question that we had, which was defining the or changing the hyperparameters, what we can do is I'll just create a new version from here, and then I'll be able to show you how we can define or change the hyperparameters. All right, so this is version 2, and before you start training, there's this drop down button near next to start training option, and it gives you three options to change options to change three hyperparameters, three change the number of, sorry, yeah, the model just got changed, the other one. So yes, I'll just continue what I was saying. So you can change the number of epochs that you want in your training. You can change the batch size, and you can also change the learning rate. So it depends on how you want to go about it and what kind of use cases are you building it for, what are the similarities between your classes, images, or objects, and so on, right? So this is where you can change your hyperparameters. Okay, coming back to the version that I had trained. So here I'm getting decent enough 99% accuracy, training accuracy, and about 96% validation accuracy. Let's go ahead and continue this process, which is testing the model. I'll just add an image that I've not used for training, and I would want to see how the model reacts to that, how the model predicts that kind of image and tells me if it's a damaged image or not. So just a moment while this loads up. Okay, I'll add my image. Let's go to the testing data, and let's see what the model says about this image. Okay, so I've added an image which is more like a close-up of some cracks on the tire, and it's saying with 94% confidence or 0.94 confidence that this image belongs to the class of damaged tires. So I'm pretty much satisfied with this prediction, and what I'll do next is go to the export model option, and this is where you can deploy the model, right? So you have three options here. One is directly download the model files, the second is getting the Docker image, and the third is deploying with an API. So I'll talk about the API part right now, but then Ayush can continue in detail, show you how you can use this seamlessly with Docker, right? So to deploy it as an API, I just have to click on proceed with nCloud, where I can deploy the model, right, and get you the inference API. Here we go. This usually takes about a minute or two to deploy the model. Again, yeah, till this is happening, if there's any other additional new question that has popped up, we can take that up.
Nope, no other questions yet. So
All right, cool. So there are multiple ways in which you can use the models, right? Depending on what your use case is, and it's also possible that a lot of, I mean, not possible, but it's quite common that a lot of use cases would require multiple types of models to reach an end goal, right? Say, for example, you want to do or you want to read the license plate number from on a vehicle, right? Then you need first you need to detect where the license plate is. Then you need to use something like an OCR, and then read each and every character from that license plate, right? So it's a process where you have multiple models involved in that entire process to reach like an end goal. Okay, so the model has been deployed, and I'll show you the inference API. Again, you have three options, curl, Python, or JavaScript, and you can take the inference API for whichever format is relevant for you, depending on what application are you trying to integrate this with, right? So this is where you can get the API, and you can also check the usage of the API right here. So right now I have not used this API, But if I had used, I would get to see what's the use, how many times it was used, what was the time taken for every inference, and so on. Okay, going back to the model, I had just started training. It actually got trained, and I'll just show you that model. So this is the process for building a classification model. And all right, so this is the model that I had started training. Now with 22 images, it's a fairly decent accuracy, but again, not, I wouldn't consider this as a reliable number still, because it's a very less data set, that it's a very small size of data set that I've used to train the model. Right, so this was just to show you that it hardly takes a few minutes to train the model and even deploy the model, get the API. I'll take another 2 minutes maybe to show you how to build an object detection model. And so we've integrated YOLO V7 here, and I'll just go ahead and create a model for a data set which I have to detect potholes basically. So I'll just show you, I'll show you till the annotation part, and then it's the same process basically. So, oops, sorry, yeah. Uh, Pothole detection, Docker con. I'll add about a few images. Again, doesn't matter how many images I add right now, because I just want to show you the labeling part. I'll just add one image right now and show you how you can do the labeling. Okay, let's take this. All right, so I've added one image and I'll just annotate that. So first you have to create the labels. So I just have one object in this, which is I had more objects, if there were more objects, I could have created multiple labels here and annotated those, all of those, right? So now what I have to do is I just have to mark, or basically draw a box around each and every pothole that I see in this image, and same thing I would do for this, and this entire thing basically here, and another one here. All right, so I've created the bounding boxes for each and every pothole that I'm seeing, and this is what you do for every image that you have in your data set, right? This is one way to go about it. The other way to go about it is also by adding your own annotated data set. So if you already have a data set which has been annotated, you have the images with the labels and the labels.txt file as well, then you can directly just zip out that entire folder and upload it here. So that makes it much faster. So this was a process where you can again, so going forward from here, it's going to be the same process where you can start training and then test and then deploy the model. So I'll go back to the deployment part actually, or actually rather going back to it, I'll have Ayush take over and show you the deployment process for Docker. That's what we're going to focus on and continue from there. Ayush, you want to share your screen and continue?
Yeah.
And maybe while we're switching screens, another question that came in was, are for different use cases or different objects, are there ideal batch sizes for training, depending on the type of thing that you're training on? Are there, again, kind of ideal sizes of those batches, or does it vary? What have you seen?
Yeah. Okay, I'll take that. So yeah, the answer, the very short answer for this is yeah, there'll be different batches and all these configurations you can change. That depends on your data set and the size of your data set basically, and also what you want to be learn. I mean to learn from the model. So when it comes to, as I said, let's say when you are training it for the first time, and if your first version of the model is not doing that great, and you find out that okay, I have very small data set, then what you can do is like you can try giving a smaller batch size, which will help again the model to learn on the smaller data set in a better way. Also, you can tweak with a learning rate, which is again very important. So these are like again, when we say it's hyperparameter tuning, so it's all about tuning whether you want to, till the time you are getting the best results, you can keep on tuning. And the whole idea of giving this experiment tracking for that reason itself, so that every time you are tuning that, you are getting the results and you are able to compare it on the platform itself. So that is a very basic thing which any data scientist or anyone can look for. So we have taken care of that part, and that's what the whole feature is about.
Very cool. Thanks for answering.
So I'm sharing my screen to explain my personal favorite Docker export. Um, Yeah. So as we all know that Docker has made all our life uh, in which was not. I mean, when it comes to deployment and when it comes to the production deployment, it's very difficult for us to keep maintain all these apps and all these deployment procedures, all these installations and all. So yes, Docker has made our life easy in that case. So what we have done is okay. So let me just make sure that I am sharing this correct screen of mine. Let me drag it here. Yeah. So on Docker Hub, you can find us, and we are under Navan.ai username, and you can look at this repository or look at this page, which I would like to share with all of you. And so we have specifically this classification base image. So as well as I was talking about the export option, that we have the base image over here in the Docker Hub, as well as you can download that from the area where Varun explained. So there was a Docker export option. If you go to the Docker export option, let me just open that. Just a second. Just a second. Yeah, so I believe that this is the first version, and I want, okay, the accuracy is also great here, which version I have trained. And when I go to the export, I can see the download Docker image as a export option. So here, there are two ways you can actually download the Docker image or pull the Docker image. One is a favorite way, that Docker Hub is a repository for all these images. And there's another way, if you are not able to pull it from there, or that's not going to happen, but okay, let's say in the worst scenario, then you can download the image file, a Docker image file from here, which is called as a base image. So this base image you can download. Along with this base image, few more things also will get downloaded. One thing is about model, your own model, whichever you have developed. That model file will get downloaded, which is important to run the Docker because in the argument you need to give the model file. Then the next thing will be the classes. So I'll just quickly show you. So, So I'm just giving a path and I'm going to download this base image. Yeah, so as I said, there'll be the next file will be classes, and then the another file will be your model file. So this is going to be your model file, which we are giving into H5 extension. So you can download that, and once it's downloaded, so it will take some time. That's why I said that this is going to be a little slow, because you are going to download the whole image, but you don't have to actually do that when there is a Docker Hub. So what you can do is you can just go to Docker Hub. So this is the page. You need to just pull this image, and you can again follow the whole set of instructions on the same page where we have given the Docker run command. So this run command, although it looks a little complex, it's very easy. So what you need to just give as a argument with Docker run, that you need to mention the volume. And while mentioning the volume, you need to mention the host directory on your host machine, the directory which wherever you are going to download all these files. So if you just give this directory along with the container directory, the container volume, the next one is you need to give a port number. You need to open the port in the environment that whichever port you are going to give, let's say 5,000 or let's say 8,000, and you also need to mention host and as well as for the container. And then you need to give the Docker image name over here. So if you download it from Navan.ai platform, then your base image will be base underscore image. But if you are going to fetch it from Docker Hub, then this is going to be your base image name, which is nothing but Navan.ai slash NStudio hyphen classification, and the tag name. This is the one image you can do use, which is stable most 1.0. And after that, what you need to give is so this is going to be a file inside the Docker image, which is going to take care of running, I mean loading the model and running the inference on top of whichever image you are going to pass with. And then you need to give this account ID. Account ID is nothing but your email ID which you are using for Navan.ai platform. The project ID is going to be along with your model file itself. So if you just see, just let me show the model file. Yeah, so I've already downloaded the model file over here. And if you just see this model file, after your model name, there is 10 characters. This is going to be your project ID. So you just need to put that project ID and the port number. Again, this port number is basically to make your fast API application to run on. So this fast API, why we have used, because again, if you know about ML development, fast API is the most favorite framework from all the data scientists all across the world to use to serve the model. So we have made this application run on fast API, which can again give you API access. The same API you can use, so you deploy with the Docker and you will get the fast API. And then at the end, you will be mentioning your model name, which is again there in your model file itself. So I'll just run this because I already have pulled the Docker image. So let me just run it. Let me open PowerShell. I hope it is visible. So quickly I'll open the notepad and I can show. Okay, so I can show here that this is my host directory where all model files are located. And this is, as I said, this is going to be your container directory. And I'm going to give port, as well as I am mentioning here the Docker image, which is there on the Docker Hub. So even if it is not available on local, it will pull it from the repo. And I'm going to give my account ID as well as the project ID which I got from model file, and I'm mentioning the model name as well as the port number. So I'm going to just hit this command and it will fetch the the Docker image from the hub. Yeah, so it is saying that it's not available on local, so it's going to fetch it. So best option according to me is like you can fetch it from hub rather than downloading from Navan.ai platform, because then you will see the huge difference in pulling the image, the speed. So I'll recommend that. So let's wait till it's get pulled. So once it loads, it will give you the API. So at this moment, it is going to be live on my local host. But the similar things you can do on your any kind of a server or any kind of a cloud platform. So you can use the same technique, and there, if you make this live, you can get the API, and that API you can integrate with whichever end application you have. So as I was saying that if this is your model file, so this is what my model file is. So I'll just show you how this is broken into two different parts. Yeah. So this is how it is made up of. So this part of your model file is going to be the model name, whereas this is your project ID, which I have mentioned over here, and the model name is going to be this. So you just need to look at your model file name. That's all. Just few seconds more. So till that time, any kind of a doubt? Okay, I think I can see a few of the. Okay, any doubt you can ask in the chat section. So it's downloaded. So starting the, I mean, it's loading the model file, and after that, if you have mentioned, uh, I mean, GPU access, if you have a GPU access and you have mentioned into the Docker run command itself, then it will going to fetch that GPU and use it for the computation. But at this moment, I don't have any GPU access on the local, so it's saying that it's not able to fetch the GPU. But yeah, that is there. There's also a way to add GPU for this. Yeah. So now it's running on my local host. I'll just show you that how it looks. So you just need to mention the address on the local host, and yeah. So this is what I was talking about. I mean, we are using Fast API, and here you can very well test, because that's why Fast API is recommended. And I'll just test with one of the image. And yeah, so you can see the response. Let me zoom it. So you can see the response body over here. The model response is there are two different classes which was there in my model. So good quality and the damaged one. And these are going to be your confidence score on based on what model is interpreting from the image. So it says it's damaged, and I'll just show you the image. So this was the image uh, I provided to my model. And yeah, it is able to give you good accuracy, as well as you can use this API wherever you want. So this is how it looks. And yeah, so that's how you can use Docker to deploy these applications. So thanks. I hope this is clear.
Thanks, Ayush. And so that's the end of what we had to discuss. Basically, it was the end of how you can build. Sorry, Mike. All right, yeah. Coming back here. So the entire object of this webinar was to show you you build vision model and Docker and other ways in which you want to deploy as well. Again, thank you, Michael. If there are any more questions right now, unless there's anything on the YouTube live stream. So thanks, Michael, again for having us. And that you want to discuss, we ate up some 6 minutes of your evening. But thanks for that. And if there's anything else, we're open to that. Yeah.
Yeah, first off, I want to say massive thank you to the two of you for the presentation that you shared with us. I learned a couple things as well too, and especially that demo there at the end made it really easy for me to see and learn how I can, plug that right into my containerized application as well too. So fantastic demos, and I've seen a couple comments coming in. Gabrielle just posted and said this was super engaging and informative. Thank you for the presentation and answering my questions. I've really been enjoying these workshops. So getting some shout outs from chat as well too. So
Thanks,
I guess
Gabriel.
before we wrap up, any final
It's a
thoughts,
pleasure
any
to
words
have.
of wisdom for? Oh, sorry. Go ahead.
Yes, I was saying thanks to everyone who's been here, and thanks for your questions. And you always can reach out to Docker, I'm sure, as well if there's anything. Yeah, that's all from my side. Ayush, anything you want to add?
Yeah, I would like to thank all of you, and I hope this explains maybe what we were thinking of. So thanks a lot, Michael, and the whole Docker team. And I would like to also thank Docker because the daily life it's really helping a lot of issues which we are facing as a developer. So thanks a lot and keep doing good work.
Absolutely fantastic. And again, for everybody else as well too, just a reminder about the hackathon. Feel free to register if you haven't done so yet. All the resources will be available on DevPost. This webinar will be available on our YouTube channel as well too. We've got a playlist that has all these webinars that we've put together for the hackathon as well too. And again, feel free to come hang out in the Slack channel as well and ask questions, get some help, etc. And we're happy to help support you. And again, thank you for tuning in, and hope to see you online. Thanks all.